All right, so very last one we're going to talk about is the elimination with multiplication method. Notice that this is elimination, just one step that we're going to do first. So if we take a look at this first problem, and we're going to use elimination and add these together, we get 6x plus x is going to be 7x. A negative y plus 4y is going to be a 3y. And 3 plus 13 is 16. So notice that when we do this, we're trying to use the elimination method, but nothing's going to eliminate. So elimination doesn't quite work. If I look at the substitution method, none of these are ready to go for substitution. Remember, if we're using substitution, we'd like one of them to say like y equals 5x plus 2, so then I can just take it and I can substitute it in. But this is not in that form, so that's not going to be helpful either. So what we're going to do, since elimination and substitution at work, we're going to do elimination with multiplication. And as you can see here, we want to first decide which equation we're going to multiply by so that we get a variable to eliminate. So right now I'm seeing that this top equation says a negative y, and this bottom equation says a plus 4y. So what would I need in order to make those y's cancel? Well, I need this part to say negative 4y. So in order to do that, I just can't put a magic 4 there. I need to make sure I multiply the entire equation. So I'm going to take this entire top equation and I'm going to multiply it by 4. So when I just do that and I distribute, I get 24x minus 4y. I got to do it to the last part too, equals 12. So I've got that top equation, 24x minus 4y equals 12. And the bottom one, I don't need to do anything to it, because now I am set up and ready to use elimination. So when I solve this and I add them together, 24x plus 1x is going to give me 25x. The negative 4y and the positive 4y are going to cancel out. And 12 plus 13 is going to give me 25. So 25x equals 25. Divide by 25. Divide by 25. And we get x is equal to 1. Once again, we want to carry it out, but we want to find both variables. So let's plug it in. Once again, plugging into one of the original equations is always going to be best. Not plugging it into the equation that we just multiplied by 4, because we could have made a mistake, and then we want to make sure that we're checking it in one that actually does work. So let's plug it into that bottom equation. I didn't touch that one, so that might be a nice easy one to plug it into. So 1 plus 4y is equal to 13. Subtract 1, subtract 1. 4y is equal to 12. When I subtract that, divide by 4, divide by 4. And last but not least, y equals 3. So I get my answer of 1, 3. So that was, basically the elimination method that we did before, only we've got that extra green step this time of we're going to multiply in order to cancel out one of the variables. It doesn't matter which one we eliminate, no matter what, you'll both get the same answer. In fact, to prove that, let's take a pause to it. We will get back to part B and answer that question, but let's take a closer look at that. So if I didn't multiply the top one by 4 and choose to cancel the y's, what could I have multiplied the bottom by? Yeah, I absolutely could have multiplied it by negative 6. So let me rewrite that top equation as 6x minus y equals 3. But this time my bottom equation, I'm going to multiply everything by a negative 6. So negative 6 times x is going to be a negative 6x. a negative 6 times a 4y is going to be a negative 24y. And a negative 6 times 13 will give me a negative 78. And then when I do my elimination step here, the x's are going to cancel. I'm left with negative 25y is equal to negative 75. And when I divide by negative 25, I get that y is equal to 3. And once again, y is equal to 3. Y is equal to 3. So both, I got y equal to 3. And if I carried out the problem, I'm not going to just to save time, but if I carried out that problem, you would get the same exact answer for x to get x equals 1. So it does not matter which variable you cancel. Whichever one is easiest for you, do it. All right, going back to part B. So part B, which variable do you think is going to be the easiest to eliminate? All right, if you said x, let's look at what we'd have to do. So if I multiply this bottom equation by something, in order to get it to multiply with the top, that's not going to really come easy. So I would have to multiply it by 7 in order to get it to be 21x. If I wanted to get the top, then I would have to multiply that by a negative 3, and then a negative 3 times 7x is negative 21x. And you can see that I'd have to multiply both the top and the bottom by something. It would still work. I'd get an answer. We'd be good to go. But remember, I asked you what's going to be the easiest. So the easiest is just going to be to cancel the y's, which means all we would have to do is multiply this bottom part by 2. So the top equation is going to stay the same, 7x plus 4y equals 17. But this bottom equation, when I multiply it by 2, is going to become 6x. 2 times a negative 2y is negative 4y. And 2 times a negative 15 would be a negative 30. So now when I eliminate this, I get 13x. My y's are going to eliminate. And that's going to equal a negative 13. Divide by 13 on both sides, and I get that x is equal to a negative 1. Let's plug it in. Once again, better be safe than sorry, so I'll plug it in the top since I didn't touch that side at all. Get 7 times negative 1 plus 4y is equal to 17. Negative 7 plus 4y is equal to 17. We want to add 7 to both sides. 4y is equal to 24. Divide by 4. And I get an answer of y equals 6. So my final answer here will be negative 1, 6 for my x and my y. So again, if you did solve for the x, you should still get the same answer if you did it correctly.